the built environment, that is, buildings and transportation to get to those buildings, in other words, our cities and towns, represent somewhere between 60 and 70% of the CO2 emissions in this country. So it's clear that we need to think of these things together. Now, what I'm going to argue is, in this talk, that while buildings are really important, they're really too small. And big utilities are really critical, but they're too big. And that neighborhoods integrate all the flows. And what I mean by that is, if you're working at the neighborhood scale, you're involved in the transportation, the energy, the water, the waste, the food, the information, and the social interaction that occurs at a neighborhood scale, including all the physical dimensions of that. The other thing is, when you work at the neighborhood scale, you can really engage the landscape. And as you'll see in this talk, the landscape is very, very important, the urban landscape. We've essentially underdeveloped that as a way to help solve our problems. And then I'm going to argue that the neighborhood scale allows you to make microgrids or micro-utilities to provide all these services. And that creates a tremendous amount of resilience with the code generation, et cetera. And that if we learned anything from the extreme weather events, it's really the neighborhood and community social networks that have enabled more quickly the recovery from these terrible events. I also want to talk about exercise, health, and well-being, all created at the neighborhood scale. Go really quickly. So almost 8 years ago, when I was working in China, in the city of Qingdao, which is where they had the sailing Olympics, this is before the Olympics, we proposed a bus rapid transit, which is the green line there, and to build a transit-oriented neighborhood there. This is a neighborhood for 10,000 people. It's 700 meters by 700 meters. And you can see the walking distances. So the first and most important step is to make this a stop here in the mid-block. The BRT has all the qualities of signal priority stations where you buy your ticket beforehand, 12-minute headways, all of that, right through the downtown. Let me go back. And you can see the walking distances are really, really direct. We were interested, could you take this high density and make it resource self-sufficient? And the answer is yes. And you do it this way. First of all, you make the buildings very efficient, and then you use wind and solar to provide the power, but the key thing is the waste stream. You take the garbage from the kitchen, you take the sludge out of the sewage, and you take the green waste from the landscape, and you make biogas that makes up the electricity backup. So now you're using waste, the garbage as energy source, the sludge as energy source, etc. You also have a combination of low-rise and high-rise. There's no one way to do this. You have to do shading, daylighting, natural ventilation, passive solar, good envelopes, efficient lighting, efficient equipment, etc. And then you can use solar, wind, solar, and biogas to power it. And the key thing here is you save energy. You can cut down the load about 40% by all of these good building strategies. That's why the buildings are important, but they don't get you there. They do 40 to 50%. And then you use renewables to do the rest. This is a diagram of a system developed at UC Davis. It's a two-phase anaerobic digester. You take your solids and your liquids. The solids go to the digester here. You get hydrogen, methane, and here you clean it in a wetland, and I'll show you how that works. That's this living machine. So you take the sludge out of the sewage, you take the effluent, you clean it here, and you can recycle it. Now, why is that important here?
You don't have to haul garbage away.
Right. But you now have water on the site. You're not using potable water for the landscape. And the biggest challenge San Jose and this whole valley is going to have when we have the heat island effect get worse and worse is we're going to have to do more landscape to try to get the temperature down. And where the hell are we going to get the water? The best place to get the water is from the waste. So this is not about transportation now. It's now seeing this as a whole system. So that's the first and most important new information I want to put in this ingredient. So how do you clean the water? You can use a living machine. There's one in the PUC building in San Francisco. There's one down at Esalen. And you just cycle the effluent through, let's go back, through these tanks. Sits there, gets clean for a while, you pump it to the next one, and you measure the quality of the water there, and that's when you decide what you can use it for. The wonderful thing about this is they're gardens. And because the water never gets above the surface, there's no smell, no mosquitoes. Okay? So, let's go back. So, you can have it inside the building, you can have it in a garden, you can have it, and if you have a freezing climate, you can put it in a greenhouse. It doesn't take up much area. You can do it in the city. So, we came up with this idea for Qingdao, and guess what? The developers were making so much money doing it the way they normally do that they said, this is a great idea, we'll do it later. So I got a sabbatical and decided I'd try to find out if anybody else had done this around the world. I went on all the continents. I went to something like 16 different so-called sustainable communities, and I wrote about 4 of them in this book. And I really, it's a very elaborate story. Let me tell you quickly what it's about. Let's go here. So these were the first generation efforts at integrated whole systems. You've heard that already. I used a very simple case study method, which was descriptive and analytic, and I analyzed these projects for their process and plan, the transportation, the urban form, green space, energy, water, waste, social agenda, in other words, of equity, etc. These were the cities. This is Bowl 1 in Malmö, Sweden. This is Hammarby in Stockholm. Kronsberg, which is outside of Hanover, and Vauban, which is in Freiburg. It's really, I could talk for an hour on each one of the projects. I'm not going to do it. The most important thing is the city provided the leadership. To get integrated whole systems, you have to get the transportation people, the sanitation people, the water people, the waste collection people, the utilities, everybody at the table trying to do things in a collaborative way, not as individual operations. So the city acted as the developer, the horizontal developer. They did the master plans. This is Bowl 1, this is Hammarby, Kronsberg, Vauban. They did some by competition, some with consultants, some the planning agency of the city did it. The city was the horizontal developer. They constructed all the public space and all the infrastructure. And they sold the lots to the developers. If you're an architect, the most interesting thing is in this project here, in this first phase, they only built 1,500 housing units, but there were 40 architects. So you automatically had difference, real authentic difference in the city, rather than a developer changing the color. Same true with all of them, and in some of them, they were very top-down. This was very top-down. The city did the plan, the city did all the infrastructure, and the city then sold little sections like this, and then put guidelines for all the buildings. This was the most bottom-up. Each one of these is a collaborative, cooperative housing project. It was a Baugruppen that people were given, they came together, they bought this, they then hired the architects, set the goals, etc. So very, very different range of alternatives. Here's the transit. So 3 of them have light rail, right down the middle. And here, one of them had a bus system because it's a more two-dimensional grid. So they just didn't have one line. The stops, 300 to 400 meters from the units. So, use yards if you want. The stops had shelter and real-time information. You knew exactly when the next one was coming. 8 to 12-minute headways. It connected to where you wanted to go. The pedestrian environment was extremely high quality, very high-grain street grid, dedicated bike system, and the most important thing is you could have shortcuts through the blocks. You didn't have to go on the streets. You could, go through a gate, come through one block, and go out the other side. So it was a really pedestrian-rich environment. I won't go through all the urban form, but basically the idea is they were all done around blocks, usually buildings on the perimeter with a courtyard in the middle. And it gives you an infinite variety of ways you can do things. And very high densities. You can get up to, we're talking about 100 units to the acre in this, which is a good density for cities. Same here, same here. This is a little lower. So just to see the block types, now this is Bow 1. Have anybody been to Bow 1? So what I like about Bow 1, you talk about the 4 and 5 and 6-story buildings, giving you a base density of maybe 60 to 100 units to the acre. Then you have this building, 350 units to the acre. And what's nice about it is you get a contrast. You get low-rise high density and you get high-rise high density working together. This person, have you been to Shanghai? Can you imagine if there are 3,000 of these right next to each other? There's no privilege in living in that. So if you use high-rise, you want to do it carefully so you get the advantage of the view. And when you do low-rise, you want to make these wonderful inner courtyards, which is what these things are. I'm not going to dwell on all these other ones. They just take fantastic advantage of the shoreline. This is Hammarby. All the units have views to the shore. This is the lake in the middle. This has a progression of the block types that are fairly high density along the transit line, all the way down to 1-story passive houses or 2-story passive houses along the edge of the landscape. So you get a real density progression. Vauban has a really interesting place. This is the main street with a trolley down the middle. You can see the trolley line here. But they don't have buildings lining the street. They have the ends of the buildings coming to the street. And they have the commercial at the ends. So each end here is a store. So you have a commercial street right along here, but you get to see into the residential areas. And the result is an amazing green space experience where you get to, here's the, you have all these fingers of green space. So these cities really pioneered in ramping up the green space to provide all sorts of services. And I'll get to that in a second. Now, how many of you really want to know about the relationship between what you need to describe as the energy, the energy consumption? Let me just dwell on this for a second. You may be interested. So, at the time, the standard in Sweden and in Germany was about 220 kilowatt hours per meter squared per year for the standard for energy consumption. They set a goal of 105, all of them, which was cutting it in half. In Goal 1, they didn't attain that in the actual measured use. They went over it by 50%. And the reason is they rushed to build this. The construction was lousy. They had too many windows facing west. It's a very windy site. But they had such a good system. They had a remote wind machine powering a heat pump that used the ocean and the groundwater as a heat sink. So they got all of their energy from renewable sources, even though they went over on the standard. With Hammarby wanted to get 50% of its energy on site. Now, Hammarby is down in a valley, doesn't have very good sun, there's no wind. How the hell were they going to do that? Has anybody been to Hammarby? So what they did is they also built quickly. People consumed 50% more than the goal. And what they did is they used waste to generate energy. Their original goal was to have the goal be down here and achieve it, but they got this much energy from waste, which is not a trivial amount. It's a little over 20%. And they got it by converting the garbage to gas, burning the combustible waste in a cogeneration plant, and actually taking the gas and using it for cooking and also for running their buses. So very inventive. The first system that really is doing this. If you take Kronsberg, they had a cogeneration making electricity and heat, and they had 3 big windmills, and they did very well. They got right on the target, and they generated a little more than half of their energy from the local resources, primarily wind. The rest was made up by natural gas. What about these guys, Vauban? Bottom up, people did this. They set the guidelines. They knew how the systems worked. They beat the goal on average, which is here. And then they used a lot of solar, and they have a cogeneration plant that is powered by wood chips. That makes the electricity and the hot water. This part of the project generates 15% plus energy for the city. It's a passive house with PVs on the roof, very well insulated, 15% to the city. This is Germany now. It's got a winter. We're here in California. So, fantastic lessons learned, right? So let me just keep going quickly. Stormwater, every single one of them collected the stormwater, retained it, cleaned it, and put it back in the environment on site. And they became design features throughout. Really inventive systems. Now, we're going to have not enough water most of the time, and then too much water a little bit of the time. And so the stormwater issue for cities, and most of the stormwater pipes are too small. So we're going to have to redo our infrastructure. How are we going to do it? These are really good models. This is, the transit spine down the middle. It cleans all the storm water as well. So they're now using the public space not just for transportation, for pedestrians, bikes, cars, and transit. They're using it for all these other functions. So I did a little calculation on waste in the United States. So this is from the EPA, their standards. If you recycle glass, rubber, metal, plastics, and paper, which we do, we don't do a very good job of yard waste and wood that goes to landfill. We could combust that. If we take food waste and sludge, turn it to biogas, this can run a cogeneration, and it can feed so much heat and so much electricity to the load of a building. This is a Title 24 building here in California, this current standard, right? If you use good architecture, climate responsive architecture and building efficiency, you can get down to about half that. So this is what we have to make up with renewables. It's easy. It's one solar collector per person for that. Just one. Easily integrated into the building or into the city. Very, very easily done. Any place in the U.S. done this? This is West Village in UC Davis. Okay? They used all of the energy conservation strategy, shading, good insulation, efficient appliances, lighting, user controls to get the load way down, and then they put solar collectors on the buildings and on the parking. And SunPower, the developer, acted as the micro utility. He negotiated the deal with SunPower to buy the electricity, and he has an annual contract with the utility. So they have a net zero deal. Whenever they're making too much electricity, the utility takes it. Whenever they need a little bit, they get it back, but it's net zero. And he's charging, along with all the other apartment fees and so on, the utility bill is part of it. And he's making money. And they're going to be net zero energy, the first neighborhood in the US. And it's all connected by bicycle paths. So they have very little parking, it's a student neighborhood. They were going to do the anaerobic digester as part of this, but they decided to use all the animal wastes from the campus and all the agricultural waste. They're making a much bigger plant, and they're going to put the gas and then use that to generate electricity and put it into the campus grid, not just to this neighborhood. Now, this is the first example in the US of doing this, and it's a developer who took the leadership here and is the agent creating the financing and the bridge to be a micro utility. So in some of your big projects, you can do that. I'm going to go really quickly. So this is really for architects, but I want to give it to you and see what you would do with this. So historically, architects have thought of the city as a spatial, formal experience. So they've just looked at the space, not the length of the space, the shape of it, the scale, etc. There are a lot of people who look at the space in terms of its social performance. What about, and lots of people have looked at trying to make the space for cities work nicely for transit, for cars, for people, really cared about the section, how you make it be multifunctional, multimodal. But what about thinking of the public space in these terms? Look at this. What does the public space potentially provide? It can temper the microclimate, reduce the heat island effect. It can clean the air. It can absorb carbon. It can clean the storm water. It can clean wastewater. It can grow food. It creates habitat. The biomass from this stuff creates energy. And then these are the more traditional things. You know, very aesthetic, makes for a wonderful place. The health and well-being impacts of this are extraordinary. If you look at the medical people, they would say the natural environment is probably the most underappreciated healing experience you can have. Recreation, community space for social interaction, and then all the transportation, all forms of mobility. So, if you're a citizen or an architect, and you looked at a typical section of the city, where you have shops and some housing above, and public transit, and parking, and, you know, sidewalks, and it's pretty much a hardscape, isn't it? Maybe there's some trees. Suppose you thought about this as a living place. All the volumes, all the ground, the facades, the roofs, the surfaces, the whole volume. What about the ground? Eco-functions. Tempers climate, absorbs stormwater, recharges groundwater, carbon sink. Co-benefits: improves comfort, saves air conditioning, relieves stormwater system, improves health, enhances senses. I'm just going to run through this quickly. What about trees? Trees pay for themselves in about 2 years because of all these eco-functions. We're going to have to plant millions and millions of trees to deal with the climate change impact on the heat island effect. What about facades? Green facades. Singapore, Europe, Paris, everybody is doing this because it lowers the heat island effect. It cleans the air. It can create shade for the buildings. And the same with roofs. Insulation, stormwater, tempers the climate, carbon sink, insulates, biomass for energy, modifies the sensory environment. What about urban agriculture? You can grow it in empty lots. Did you know that Cuba gets 70% of its agriculture from urban agriculture? And that's because the Russians took the industrial agriculture out of Cuba. So they grew it in their cities. So you can grow it on roofs, you can even grow it on walls. What about the storm water? These are all from Portland, by the way. Got to remake the storm water system. So why invest in bigger pipes? This is cheaper, much better, makes for a greener environment. Or you can dig wetlands. This is China. This is all the sewage from these guys, cleaned here. Here's the living machine diagrammed a little more carefully. Treats wastewater, absorbs carbon, tempers water value, energy value, carbon. So we are just starting to understand all the co-benefits that we can get if we engage that space, the public space, in terms of its environmental performance, not just its transportation, the traditional ways in which it's been used. So there it is. Now, why? Okay. So where are we on this chart? This is from Peter Calthorpe. He did this as part of the planning that went to some of the legislation that's been passed. This would be the trend in 2050. Buildings, transportation. This is smart growth, which means we're trying to build around transportation. This is much higher vehicles, higher performing vehicles. This is biofuels. You can see the transportation coming down, right? This is creating much greater building efficiency. This is green power. This is where we need to get. Those 4 projects that I showed you are the only ones I know in the world that are at this level. So that means every single thing we build from now on until 2050, we need to be aspiring for this, which means transportation is part of it. We've all seen that today. But the whole system integration of energy, and especially water here in California, and waste need to be part of it if we're going to make it. If we're going to get to this number here, that's what we need to do.
And what I'm happy to say is that the City of San Jose is very much taking the lead from a United States standpoint in doing a lot of this waste to energy stuff. So that's what I'm going to talk to you guys about. So in particular, the City of San Jose 10 years ago really saw an opportunity. Our commercial waste stream had a very low diversion rate, and what I mean by diversion is a good portion of the material that we collected from businesses ended up in our landfills. And so we as a city had a goal to get to zero waste, and we're not there yet. We have an ambitious goal, and we realized that our commercial program was something that we really needed to tackle in order to get to zero waste. And how this really ties in with what Dr. Fraker has been telling us about is sort of how do we have a closed loop system? So there's all this material that's going to our landfills. How do we harness the energy from that material and make it once again contribute back to the community? So this is one example of how our commercial program had been redesigned in order to be really a much more closed loop system. So this was not something that the City of San Jose did alone. We actually have invested pretty significantly with private partners on this endeavor. All of the contractors involved I'm talking about is coming from industry. The technology is coming from the private sector, from Europe actually. And let me tell you a little bit about our commercial system. So we had over 8,000 businesses, we still do, in the City of San Jose, and what we had before was what we call a free market system. So any business could go to any hauler, private company, and get their garbage and recycling taken away. And because of that, that was great probably for the businesses because they could negotiate rates, but we were getting a lot of inconsistencies in terms of looking at that waste stream. In general, the commercial waste for the city encompasses about a third of what the waste stream is. So the majority of waste is from a residential sector, but the commercial sector is still very substantial. And at the time that we were thinking of this redesign of our commercial system, we had 24 different haulers that were operating in the city. So some of the challenges with the way things were is, once again, a very low diversion rate. I'm going to talk to you about that. We really didn't have the leverage to say to a company, hey, we have higher standards, we want you to have higher standards, because they were just negotiating with businesses on their prices. And that was great on that one very, interesting point, I'm sure, for businesses, so I don't want to diminish the fact that that was a very cost-effective system for them, but really it did not tackle any of the environmental issues related to waste collection. And there was really a need to develop a system that could finance some big infrastructure improvements that were needed. So a lot of the things that we're talking about, anaerobic digestion, biogas, really having a higher diversion rate, that means having really processing that's very expensive. And we couldn't finance that processing without some big changes to our system. So our waste diversion in San Jose, if you look at the top line, that's what our overall waste diversion had been. And what you can see is that our commercial waste stream is that lower line at the bottom. So we're commercial, that takes up a third of the waste stream, but it really was bringing down our diversion. And what we did before we redesigned the program is we did a waste characterization. What was out there in our commercial waste stream? And what we found is that about 80% of that material could have been recyclable or compostable, yet we were only diverting 22%. So there was a real opportunity for improvement. We also had at the time really ambitious goals politically. We have the city of San Jose has is a green vision, so 10 really ambitious goals. And what we thought this particular redesign could tackle was clean jobs, renewable energy, and the biggest, of course, being zero waste and converting that waste into energy. We also developed a zero waste strategic plan, and that helped guide the redesign as well. So we had a very extensive RFP process, lasted multiple years, and we were looking at really two different things: collection of the material and processing of that material that was not organic, and then the second part, which was the processing of organic material. And what we decided on through this extensive process, which I'm highlighting in just one slide, but took quite a bit of time, was we came up with a new commercial system that had two big vendors: Republic Services, which collects the material and processes all the material that's recyclable. And then all the organic material is delivered to Zero Waste Energy Development Company, which is a brand new facility that has opened, and it is an anaerobic digestion facility. So the one thing I want to note about our new system is that no material that comes from the commercial system in San Jose goes to a landfill directly. Everything goes into processing to make sure that we can get the highest and best use for those materials. So all the material goes to a MRF where it's sorted and recycling materials are pulled out, and then organic materials are pulled off to the side. And if the material is clean enough, like from a restaurant, for instance, when I say clean, I'm sorry, I'm talking kind of a clean organic stream. If that material is a clean organic stream, then we can have that directly delivered to our anaerobic digestion facility. So through all of that, yes, there is some residual that does go to the landfill, but we really are trying to make the biggest, steps possible and not having that be the first step. So Republic Services, because of this large contract that they got for the commercial program, which I have to say is so large that it is larger than most cities in our size, our neighboring cities' entire commercial stream. Entire waste stream. So the city of San Jose's commercial program is larger than, say, the waste stream that's coming out of the city of Santa Clara or the city of Milpitas or many adjacent cities. So this is a very large redesign. But Newbie Island, which is the recyclery for Republic Services, obviously needed to be adjusted pretty significantly. So now it is the most advanced materials recycling facility in the world. We have people coming every month from different countries, from different states, because this is a very efficient system, and it's able to handle quite a bit of capacity. Another thing to note is all of the vehicles, as part of this new contract, all of the Republic collection vehicles are now CNG clean, so that was an added benefit. I think I'll talk about that later a little bit. So the other piece of this is the organics processing was awarded to Zero Waste and Energy Development Company, and the technology that they're using is a tested European technology, actually out of Germany, and it's really dry fermentation, which is fully enclosed in what I call tombs. Let me see if I have a photo of it. You can kind of see it over here. And really what's great about this is that every time we try and process waste, there's a concern of smells, odors, stuff like that. This entire system is designed to really eliminate or minimize odors in general. It's also obviously the biggest benefit is it's able to efficiently process the organic material and capture that methane and use that methane in a way to, in the instance of this particular technology, power its own facility. So this facility uses energy, but all that energy comes from the organics that is being digested. So really, this infrastructure is something that is pretty significant to this region. The City of San Jose's commercial program is going to utilize about a third to a half of the capacity of ZWED, as we call it. But there is going to be room for other communities to now start sending their organics material to it. So that's great. It was a large enough of I guess, an investment, right, for ZWED, that they are building this facility at a scale that our region is going to benefit, not just the City of San Jose. So really, this commercial redesign helped us meet our green vision goals. We added 200 more regional green jobs. We are going to get to a diversion rate above 75%, but that's roughly where we are now with our commercial program. We have 50 alternative fuel vehicles, and we are doing that. We are generating renewable energy from waste. And so this, previously very inefficient system has been changed to be much more efficient in really a one-year time. I mean, the planning of it took a decade, but actually changing the system was, we saw our diversion rate triple in just 1 year. The other thing that I wanted to tell you guys about, and I'll take a step back, is there's another waste-to-energy project that the City of San Jose is piloting right now. It is with a grant that we received from the California Energy Commission, in which this is our wastewater treatment facility. We are using two feedstocks that are not really utilized very well here. That's our biosolids that come out of our wastewater treatment facility, and those biosolids currently are used as cover for our landfills, and so that's not a good use of that resource at all. And another is our wood waste that comes from our residential program. And that wood waste, so a lot of trimmings, yard trimmings, right now is often sent to the Central Valley and is boiler fuel. So we want to keep that material local and use that material as a local resource. So the particular demonstration that we're doing is a gasification unit. It's going to actually be on our wastewater treatment facility's site. And what gasification is non-combustion, so we're heating up the material, but it's not actually burning. And energy is being transferred and created what's called syngas, and that syngas can then be changed into CNG or other types of gas. So what is very hopeful for us is that we're going to be able to take this demo and pilot it within our local environment, right? The California air and water regulations, which are the highest in the country, and our local feedstocks. And so we're hoping that through this pilot, we're going to see that this is a very useful technology, that we can do something constructive with these materials, and that we're going to be able to produce energy from them. So you can wait and see on that. But just kind of the tie-in to Dr. Fraker's whole presentation is the City of San Jose is, attempting to do this, obviously not on a neighborhood scale, but on a city scale. And we're hoping to lead the country. Other people can learn the lessons of a larger city taking steps to do these waste-to-energy conversions. And so we're hoping that the city one day can be a closed-loop system, that it's zero waste, and we're generating energy. And so this is one of our steps, pretty big steps to get there. Thank you.
All right, so thanks everyone, and I just want to again thank Dr. Fraker for joining us today. It's a real honor to have him here, and really learning about this whole systems approach, integrating waste to energy, having the transportation network, and thinking about livability and open space and so forth. And so I want to highlight that there are actually some opportunities to potentially incorporate some of these principles throughout Santa Clara County. And some of you hopefully have seen this, that was included in your packet. These are all the transportation and land use plans taking place in Santa Clara County over the next year. That means that's an opportunity hopefully in your city to be able to participate in a planning process and be able to push the ball forward, because I think what Dr. Fraker has really instill in us today is that, number one, we have a long way to go in order to achieve low carbon communities, and some of these steps that we can take in order to get there. So some examples of what is going on in Santa Clara County, just next door in Mountain View, there are 3 precise plans currently undergoing a planning process right now where you have an opportunity as a Mountain View resident to participate. There's a San Antonio precise plan which accounts for 123 acres. It's right in between El Camino Real and the San Antonio Caltrain station. El Camino Real is the highest transit ridership corridor for VTA's system, and VTA is currently planning for a bus rapid transit system along there all the way from Palo Alto to San Jose. So it presents an opportunity for TOD in the fullest extent. And one of the other principles that Dr. Fraker talks about is having these pedestrian corridors, open spaces, densification, those kind of things. Those are all components of the San Antonio Precise Plan, as well as good urban design that they're thinking about right now. Also, the city of San Jose, you have roughly 7 urban villages that are the city is going to be embarking on planning over the next several years, and that presents a huge opportunity to look at some of these corridors, some of these areas, some of these spaces that Fraker talks about, Dr. Fraker, that are perhaps underutilized, tired commercial centers and so forth. So I'll give you one example. On South Bascom Avenue and West San Carlos Street, they're currently undergoing that urban village process right now, and the council is about to adopt those plans within the next week or so. And so this is the area, West San Carlos Street, South Bascom in San Jose. You can see that they're looking at various different uses, such as mixed-use residential character. This is Bascom Avenue. They're looking at different kind of transportation improvements to incorporate more crosswalks. How many of you guys have ever been on Bascom Avenue? Okay, yeah, right? See some of those facial expressions. They're not facial expressions of excitement, but this is probably why, right? So this is Bascom Avenue, and what the city is envisioning is actually to have a road diet where they're going to put in separated bike lanes, and so in landscaping and whatnot. So, how much landscaping do you see there? Crosswalks, you don't really see any, right? And there is a bike lane, so that's one thing I will say. But what would a world look like if we, incorporated separated bike lanes with landscaping? You can see there enhanced crosswalks. All of a sudden, it creates a much more walkable environment. You see the crosswalks there, and you start getting more and more people to walk and bike and use these zero-emission forms of transportation, right, that are also healthy for us. You see this here is another example of what they're envisioning. And so, these kind of strategies are possible. There's cities that are looking at it, but we need advocates like yourselves to go out there and really push for these kind of improvements